You're hearing is Steve Curlin. I'm the Education Director at the Stroud Water Research Center. Also in the room with me, tag teaming on the webinar today is
Dave Arscott. I'm Assistant Director at Stroud Water Research Center. Welcome, everyone.
And time-wise, Dave, are we at time to start? What do you think? Or one more minute? Close to it.
Give it one more minute.
All right, we'll give it one more minute. Seems every few seconds more people are adding in on our attendees list. Yep, there's a few more also. Yeah, as we're waiting to start in a little bit, I do want to let everyone know that we are recording this webinar so that it can be archived, and it will then be placed on the WikiWatershed.org website. That way you can go back and review it later, and you can also distribute it to your colleagues, and we'll do the same. We'll distribute it to others also. So it will be archived, recorded and archived, and displayed for the public. By default, since there are so many people joining us today, you are muted as attendees when you enter, and we're probably going to proceed that way throughout the webinar. So that means please do use the chat window or the Q&A window to pose some questions. We'll probably run straight through some things for the first half or so, or a little more of the program, and then have time to answer questions in that chat window or that Q&A window. Will be the places where it'd be easiest for you to write in your questions, and then we'll answer those questions. We'll repeat the question and answer it out loud for everyone while we're showing you different features. So I think let's go ahead and get started. So this is our webinar for the WikiWatershed webinar series, Model My Watershed for educators and other similar users. But I'm sure we probably have some other people on the line that might be citizen scientists or other watershed professionals. We'll have information, hopefully, that everyone will find useful. So what is WikiWatershed? WikiWatershed.org is an online toolkit for watershed professionals and educators. It's a collaborative project between all the people you see listed on the side as a leadership team and all the different organizations that they represent on the right. The Stroud Water Research Center is the lead organization, and we have partners from a couple other universities, Utah State, Washington, University of Washington, Millersville University, and then other organizational partners, Concord Consortium and Azavia is our programmers. And major funding is from National Science Foundation, a Discovery Research DRK-12 grant called Teaching Environmental Sustainability, Model My Watershed, and also from the William Penn Foundation, and specifically with the Delaware River Watershed Initiative. So current resources that you can find on wikiwatershed.org are Model My Watershed, which is the feature of today in today's tool, and that's what we'll spend most of our time on, showing you lots of different features for especially education users, but also other users. So we'll come back to that one and spend most of our time on it. The Microsite Model is an animated simulation and it's a simplified version of the Sightstone Model, the 24-hour storm event model that is embedded into Model My Watershed. The Enviro DIY is a community of do-it-yourself enthusiasts interested in environmental science and monitoring, especially in streams, and it includes information and discussions about low-cost data loggers and our new Mayfly version of a data logger that's available from the Stroud Water Research Center. Other resources currently on wikiwatershed.org are Model My Watershed, which is still in a build stage, which envisioned as an app for map-based discovery, visualization, and sharing of data from a number of different sources, to assist educators and citizen scientists to monitor their watershed. Also embedded in to WikiWatershed.org is a portal to the LeafPack network, which is an international network of stream monitors that collect data about their local streams and upload it to a database that is viewable by everyone internationally. So you could collect your data, compare it over time, and also compare your local stream data to somewhere else in the country or somewhere else in the world. We have some future resources that will be coming soon. One is the Manage My Watershed tool, and this one is more of a social networking web app or a platform for a community of people to engage in practices of managing and sharing resources about their watersheds. And coming very soon, probably within the next month or so, is the Water Quality mobile app. And that's a data collection tool for mobile devices, tablets, and smartphones. It includes a digital field guide to basic macroinvertebrates at the order level, the ability to collect data, chemical and physical data, and a site profile, and to export that data, and also includes learning pop-ups to help users make sense of the data that they have collected. And so the portal looks like this. This is when you go to wikiwatershed.org. You'll see this currently, 5 tools in the toolkit. And as mentioned, we're going to be focusing today on Model My Watershed. And since this this webinar has a primary audience of educators, I want to also mention that we have a pilot curriculum that everyone can go and check out. And that curriculum is a 5-day unit activities designed for early high school, so 9th grade, but also some middle school. So 7th and 8th graders are implementing this pilot curriculum. And we're testing and piloting that curriculum in 5 states currently: California, Virginia, Pennsylvania, Kansas, and Iowa. And we have 2 more years left on that National Science Foundation project. And if you're interested in getting involved in implementing a pilot curriculum with these, or actually we'll continue to revise these lessons, please contact us. And you find that pilot curriculum at the ITSE platform, which is the Innovative Technology and Science Inquiry website. So let's go ahead and we're going to dive right into some of this. And I'll show you live the ITSE platform, WikiWatershed, and then spend most of our time with Model My Watershed. I'm going to move out of the PowerPoint, and we'll go live on the web. Let's show you that ITSE platform first. And you can sign in and get a login if you like, but for now we're just going to explore the ITSE activities. I'll show you an example. So we've got these activities under ITSE portal.concord.org. There's the website. And we want to look under High School Environmental Science to find the Model My Watershed activities. And here they are for you. As a guest, you can view the activities and work your way through them as guest. If you do create a login, the ITSE platform has the ability for you to completely customize the lesson plans for your classroom, for your learning objectives and the needs of your students. So let's take a look at an example 1. Part 5 actually is an example lesson that uses Model My Watershed. And they're all inquiry-based lessons, starting with essential questions, some introduction, aligned to standards and learning objectives, and then we dive right into, and you'll see here embedded into the ITSE platform, are some of the features and tools and processes that are part of Model My Watershed. And this activity guides students and teachers through how to use Model My Watershed to model practices, to gather data, to analyze land cover and soil data, hydrologic soil data, and then to model, use one of the models in Model My Watershed, which is the 24-hour storm event. And then also within that, to make changes to land cover and or changes to conservation practices that you may want to implement within a selected polygon, which in this unit is a 1 square kilometer area around your schoolyard. So that's embedded right into that ITSI platform. Let's go back now and let's look at, here's our home, WikiWatershed.org. As I mentioned, there are the 5 current tools. There'll be other tools in the toolkit that will be added over time. There's some news events at the bottom, so you can stay up to date on new resources and new features. And also, I mentioned that this webinar is being recorded and archived, so you'll be able to find that. I believe it's, I think this is the right place. Yes, under the video section at the top, we'll add an archived version of this webinar. Also available here is an earlier version of an archived webinar that is more of a technical webinar that gets a little more behind the scenes of what are the algorithms and what is the data and the databases and the data sources that are behind everything that you'll see in just a minute on Model My Watershed. And we'll likely do another one of those within the next few months as Model My Watershed keeps getting updated. We're on our rapid release cycle. Every 6 weeks, there are new features and fixes coming out. So please do check back over time. So let's go ahead and we'll go back to our landing page, and all you do is just click on Launch the App. And here we go. It's logged me in. I have a login. You can log in as a guest, or you can create a login as a user. It's free to create your login, and we do recommend that you do that. It does 2 things that are really helpful. The first thing for you is you can store projects. So here are some different projects that I've stored. I can make them public, and I can share them with other people, and then you can send the URL to anyone you want, and then they can also work on the same project, or you can share what you've modeled with them. So that's really helpful to go ahead and create a free login once you start exploring Model My Watershed on your own. The other thing that creating a login does and logging in to use the online app is that it actually makes the app, the online or the web-based app, faster. Because every time you do a process through your login instead of a guest, the processing of that will be saved or cached. We can think of, and if someone else or you in the future try to do the same process, it will be faster. So do go ahead and log in as a user, create a login. So let's take a tour of Model My Watershed. We'll start in the top left, choosing an area of interest, and we'll type in the address for the Stroud Water Research Center, which is 970 Spencer Road, Avondale, PA. And this will zoom to that location. One of the things that I really like about Model My Watershed is the speed and the usability. I've used a number of other GIS platforms. This is online. It is free. You don't have to take a number of GIS courses to understand how to use it. You don't have to read through long manuals. If you can use Google Earth, you can use Model My Watershed. So here's our current location at the Stroud Water Research Center. By default, it just gives you a kind of plain Google type of map, which is a street layer view. And you have a number of options here in this layers function, which is under this show layer control. This is actually a little globe icon. So that's the street view. We can switch to satellite view, and you can see an older picture of the Stroud Water Research Center. There's a brand new LEED Platinum building here right now. And you could also switch to satellite with roads, and this is a newer version, so you can see the entire area around the Stroud Water Research Center. We'll zoom in, we can zoom out. Also available is a terrain layer, which shows you changes in topography. And you can see that with the shading So this is a relief map. It's not a topographic map. It doesn't have contour lines. It would be a relief map. The base map layer that I like and probably use the most is this satellite with roads. So we'll work in that one for a little while. Let's next go to overlays. Right now we have a number of options for stream overlays. I have none of them enabled. One that is available across the entire lower 48 is this National Stream Network. And as I clicked on that one, you see a blue line. And this is White Clay Creek that runs through our property. And let's zoom out. And as we do that, you'll see more and more streams appearing. We'll continue to zoom out a little bit at a time. And you'll also notice as we zoom far enough out, you'll see that major streams are in thicker blue lines, or major rivers are in thicker blue lines, and smaller ones are in smaller or thinner blue lines. And we can keep going out a little bit more, and you'll see that rendering when you zoom out. So far, the smaller streams go away. And this, like I said, that one is available across the entire lower 48 states. So we're at the level now of major streams, major stream networks. So that's the National Stream Network. Let's zoom back in. We're close to Philadelphia here in Avondale. And you're seeing the speed of Model My Watershed as I do this. And this is live on the web as I'm navigating through. If you happen to live in the Delaware River Basin, which is eastern Pennsylvania, a little bit of Delaware, a little bit of New Jersey, and a little bit of upstate New York, then because of our partners, funders, the William Penn Foundation, we're piloting and using some more detailed data layers. So if you're in the Delaware River Basin, then you can see even more detail, even down to the point where projections of intermittent streams are shown on the map. So you've got that within the Delaware River Basin, you have those more detailed ones. There are a couple other options here in the Delaware River Basin, but we're not going to dive into those. I'll let you explore those on your own. I'm going to go back to the National Stream Network because I know we have people from all over the country joining us today. If I scroll down a little more on the boundary overlays, other things that you can add, let me zoom out a little bit. You can add boundaries for HUC watershed units. So Hydrologic unit code is what a HUC is. And these are from the USGS, and these are watershed or sub-watershed boundaries. And you have the smallest ones that are available, and these are HUC 12 boundary units, and you can see those in this reddish or pink color. And as I zoom out, and now you can see the boundaries. Let me click on none there and show you another place you can do this with the boundary layers is near the top left. And if you do the same thing up here, say for instance our HUC 12, if you use the tool up in this area, you actually also get an overlay that tells you the name of the different watersheds or sub-watersheds. And so you can just scroll back and forth and come up and see the different names. So we're located in the east branch of the White Clay Creek HUC 12 sub-watershed. So that's one option. You can also enable county lines, the borders of counties we've shown, and with the overlays, that tells you the name. You can overlay congressional districts. So if you want to know which congressional district you're in, or if you are noticing an issue about something, this will help you as a guide to know who to contact in your congressional districts. And also one of the features I like is the school districts. And so you can see the boundaries of all the different school districts. County school districts in some states, other school districts in other states have boundaries made by other ways, not by counties. So those are the different boundary layers you can see and select from either up here at the top, let me reset that, or under this overlays overlays function. me show you a couple other neat features. The models are based on two different databases, and run on two different databases. One is the National Land Cover Database, so we'll enable that one. And this is for the lower 48. National Land Cover Database is color-coded and matches the color code from the USDA. And the same goes, it will tell you, if it's a forested area or an urban area. So obviously, dark greens are forested areas. Yellows and similar colors are agricultural areas. The same in browns also, and reds are urbanized areas or areas with high density of development. As I'm talking about that one, I wanted to jump back and show you. Right now, we don't have a key for all those colors, but that's coming in the future. But if you go back to this Microsite model, this simulation that I mentioned earlier, you can see all of those different colors in these pop-ups and the explanation for what they represent. So low density development, medium, high density development, forested areas would be that green color, and the description that goes with them. So this is our simulation model, the model that changes within that 24-hour storm event. But it also works as a key or a guide for you for all the different colors, both for the National Land Cover Database, and the next thing I'll show you, there's color groupings for the hydrologic soil groups. So those are all there. So let's jump back to, which one was I at? Too many windows open. There we go, we found it. All right, so National Land Cover Database is one database you can add as a layer. You can also change the transparency of it. If you want to make it a little less or more as an overlay, more prominent, so you can see that layer control or that transparency control on the side. Mentioned also the second big major database that we're accessing is the hydrologic soil groups, and that comes from directly from the USGS, the United States Geological that's USDA also. Sorry, USDA also, and these are just the hydrologic soil groups, not all of the soil groups. And again, if you go back to that Microsite model, that simulation, it will give you the key for these. Let's zoom out, and you can see more of those, and you'll see that ones that are darker in color are typically found around streams, and that makes perfect sense because they have a higher clay content and smaller particles that have been washed down into the valleys and the areas and the stream beds. So the National Land Cover Database and the hydrologic soil groups are available there for you. If you live in Pennsylvania, you also have a layer or a coverage layer area that shows you where there are urbanized areas. So this is this shading that's in gray. We won't spend too much time on that. And then DRB means Delaware River Basin, so there's some extra things there for those of you in the Delaware River Basin. Let's turn that one off. Zoom out a little bit. Not quite that far. There we go. And let's also turn our streams off, and then we'll click over to observations. And this is something that's being piloted, so it's not available across the entire country yet. But one of the interesting things is that we've added is the USGS, the United States Geological Survey stream gauging station. So I'll just click on one for an example here. And here's our river gauge station for this location, last updated 2 hours ago. We're pulling directly from the USGS website. You can see that in this case, this one is gathering data about discharge and river stage height. Some other gauging stations may have some additional information. You can also see historical data. And this is live, pulled right from the USGS, all in one place for you, so you don't have to go back out there to search for it. And you can in this case, the discharge or river stage height, which is kind of similar data. You can look at different points in time. You can also change the amount of time into the past that you want your graph to view. Yeah, this is an interesting one. Some interesting data on that one. But we have the USGS gauges for gauging stations for 214 sites currently within the Delaware River Basin, and hope to add more of those across the country as we go into the future. Another interesting one also within the Delaware are these permitted point sources. So these will provide you with information about point source discharges that are permitted by, in this case, by the state of Pennsylvania. So you could look up that information, and this would be things like municipal sewage treatment plants, or maybe power plants, and other discharges that are permitted. These are not current values of what they're discharging. These are what they're permitted to discharge, the data that's provided to you there. All right, so those are some other examples of just data overlays. So now let's really dive into doing the modeling. I think I do want to turn on the national stream network as we do some of this. And there are a number of different ways you can first choose or select an area. Let's go back to zoom back in on the Stroud Water Research Center. All right, so it'll take us back to our location here. And we've got our east branch of the White Clay Creek. So you can draw an area in a number of different ways. First thing you can do, let's do the simplest first, is this square kilometer. And this is what's in the current pilot curriculum that you can find on the ITSE website. So drawing a square kilometer very simply is selecting that option and then clicking on a spot. And now we've selected an area, a 1 square kilometer area around, in this case, the Stroud Water Research Center. And now it's analyzing data from a number of different databases, specifically or particularly that National Land Cover database and the Hydrologic Soil database, but also a few other databases about animals, point sources, and water quality. So it's spinning here, doing the analysis, and there we go. This 1 square kilometer tells you the total land area. We first are selecting land cover. So again, all these colors are matching up, and it's recognizing that they're there, even though we do not have them selected as one of our overlays. It still knows these are all there. So you don't have to clutter your screen if you don't want to, or you could see them being represented. You can see, in this case, we have a large amount of green, which is our deciduous forest. We also have some pasture and some cultivated crops, the 3 largest types of land cover, represented by the 3 most dominant colors within our 1 square kilometer. And so the model knows that those databases are present, even if you don't have them enabled. Go ahead. This is from a version. Thank you, Dave. This is National Land Cover Database version 2011. So as soon as they'll come out with a new database, it automatically updates it because it pulls from the original database file. So the current view is the 2011 version. And you've got all this information both in graphical form in a bar graph and also in tabular form down below. So you have that for the land cover. You also have it made available to you for the hydrologic soil group. And again, even though you don't have the hydrologic soil groups shown, the model knows it's there, and it's pulling on that database and putting that in, analyzing it for the 1 square kilometer that you've selected in both bar graph and tabular form. There is some other information available about animals, and this is it comes from county data, county reported data from the census. and then estimated within the county for the area that you've selected. There's area about those point sources that I showed you earlier, but that's only available in the Delaware River Basin, and there's no permitted point source discharges within this 1 square kilometer, so there's no records found. And there's also some information about water quality. Again, that we're testing and building this in the Delaware River Basin first. All right, so let me go back, and we'll hit reset. We'll clear our screen a little bit, and I just showed you how to draw area with a square kilometer. The other thing, another next thing you do is draw an area by doing a free draw. And you can create a polygon of any size and shape that you like. So let's say I'm interested in this area, and we'll cut across to here. We'll follow Spencer Road down to East London Grove Road, and then roughly back up. So now I've created a polygon of an area of interest, and this is my area of interest around the Stroud Water Research Center, some forests surrounding the stream, but also some agricultural land. It does all the same things I showed you before, analyzes the databases for this polygon of any size and shape, gives you the land cover, the soil, the animals, point sources, and the water quality information. Excuse me, the throat's getting a little dry. So the next thing we can do is we can create models based off of within our polygon, and we can model a couple different events. Oh, no, actually, before we create models, let's go back. There's one other way. Actually, there's two other ways. You can create boundaries. We can go back to our hydrologic units that we had earlier. Let's zoom out to one of those, and if I double-click on the hydrologic unit, the boundary, it selects the whole hot boundary and quickly analyzes it. And there's our information for that whole sub-watershed. The East Branch of the White Clay Creek, Hut 12 sub-watershed, happens to be 87 square kilometers. And here's all of our land cover data and our soil, hydrologic soil group data, animals, point sources, and water quality. So you can work on a number of different scales, and you can select different boundaries according to your area of interest. Let me go back again. And the last way that you can select a boundary, I'm going to zoom in a little bit before I click this one, is you can delineate a watershed according to a stream network. So let's say, let's imagine that a water drop landed right there, close to this stream. It's spinning, it's doing some work. What it will do is find the shortest route, a direct route to the stream, and then it will delineate and create a boundary for the watershed upstream of that location. I might have selected one that's a little big, no close to a stream, we'll see. So we'll give it a second or two, and I'll get a drink of water. Yeah, delineate, thank you, Dave. Delineate watershed, this process or this tool currently is only available in the Delaware River Basin. Oh, unable to delineate. I got an error. We'll try one more and just see what we get for today. Let's click one right there. We'll give it one more try. There we go. I didn't get a whole stream reach just because I picked a random area. But the idea was I selected this purple point, and it's immediate. Oh, I should pick. Sorry. I should show you the. We need the detailed. There we go. Delaware. Since we're working in the Delaware here, I picked this point. It picked the spot immediately down to a known stream. This is not a permanent stream. That's probably why I didn't shoot directly to that. This is an intermittent area. And what it does is tells you that everything within the boundary you've now delineated, if there's runoff, it would eventually end up at this point. So now you can calculate, you can analyze this area, and then we can do some modeling with that area using the algorithms that I'm going to show you next. And so that Delineate watershed is available in the Delaware River Basin. Let's go back. We'll reset. We'll clear those. Let's find our location again. Everybody's going to know the address of the Stroud Center by the time we're done today. Let's go back to that location. Zoom out a little bit. And let's go ahead and we're just going to pick, we're going to draw an area and do a free draw. And we'll pick, I'm going to go around these roads, which basically encircle the Stroud Water Research Center. So if we look at that area, we've done a border of the roads that surround where we are located. I'll go back to the National Street Network. I'll turn those letters off. So now we want to show you the modeling. And there are two models. First one is the Sightstone Model, and this is a single storm event that models a 24-hour storm. And then the second one, which we'll come back to and show you in a little bit, is this Watershed multi-year model. And that models the precipitation and other information we'll show you shortly over a year's worth of time that is averaged from precipitation data over a 20-year period. All right, but let's do the Sightstorm model first. So we want to model this area. We've already analyzed it, and we have a lot of information. Now we're modeling a 24-hour storm event. We look over here to the top left. By default, it models with a 2.5 centimeter 24-hour storm event, so that's a little more than an inch within a 24-hour period. You can change that, and if you want a larger storm event, let's say something, there we go, how about an 11 centimeter storm event? It's processing, anytime you see things spinning, there we go, it's done already. It will model the amount of evapotranspiration, runoff, and infiltration. And in our curriculum, the major goal, as students are doing the modeling at least, is to try to minimize the runoff, minimize the amount of potential runoff and pollutants that are going into our streams by surface flow. We try to increase the amount of infiltration. So we've got that information in both a bar graph and in a tabular form here again, so you can see more detailed numbers out to more detailed decimal places. So we have that runoff information. We also have water quality information. Included in that is the amount of total suspended solids, amount of nitrogen that would run off into the stream, and the amount of phosphorus. So it's also shown below in tabular form, suspended solids, both as a load, loading rate, and average concentration. All right. So within our, go ahead, Dave.
So the runoff calculations here are using a modification to a well-known algorithm called TR55 that was developed by the USDA many years ago, with some added coefficients for urban landscapes from Dr. Robert Pitts's publications. The water quality model that is being utilized here is called the EPA Step L model, and it's a basic model for quickly estimating total suspended solids, total nitrogen, total phosphorus in runoff, connected with the TR55 model.
All right, thank you, Dave. Next thing we want to show you is how you can create scenarios and models. If I click on New Scenario, I get a couple other options. One of the things we can do is we can change or model a change in the land cover. So let's say, for instance, we know we have some agricultural areas within the area I've delineated. Let's say I'm interested in changing some of them back into a forest. So I clicked on forest, and I create a polygon, and now we're modeling what happens if I change that agriculture area back into a forest. How does that change our runoff and our water quality information? We can name those, rename, say we change them to forest. I can create as many scenarios as I want. I believe there's no limit on scenarios. And we can continue, we can model other types of things. Maybe we're changing, yeah, we should put, what if we could put a medium density housing development? And let's say we're going to put that in this area, in what used to be a forest. So if we do that, you're thinking as it's calculating, I mean, what's that going to do to our amount of evapotranspiration, runoff, and infiltration? Most likely take our runoff and increase it. Now, you could do multiple scenarios with multiple changes within the same scenario if you like. The other thing that you can model, in addition to changing land cover, with right now 12 options, is you can also model changes in conservation practices. So in these cases, so for now, we have these 6 options. Likely also be more of these in the future. Maybe we want to change some of the agricultural area to no-till ag. So instead of tilling and creating in row crops, we're going to use no-till ag. So let's let's say it's this area roughly, and you can draw these a lot more precise than just doing the polygons fairly quickly. So if we change that agriculture area, that farmer decides to adopt the conservation practice of no-till ag, how does that change? And how is that modeled? So we can also, let me revert it back to default. Let's put it up at our 11 centimeters for a rain event, so we see larger effects. Ooh, it's 412. I got to move along. Last thing to show you on this section is that you can compare. So you get the compare button, then we see all of our different scenarios that we've created side by side, and you can see those different changes, and especially illustrated here within either runoff or infiltration. You can change the amounts on the bottom of your precipitation, and that would change all of them also. You get a list of what changes you modeled, forest cover here. This one's the current conditions. We put a medium housing development in here, and we did a no-till conservation practice here. If you hover over them, you get, so here's the difference between current practices, current conditions, 5.1 centimeters of runoff, compared to our scenario of medium density housing development, 5.8 centimeters of runoff within a 19 centimeter storm event in this case. All right, so let's quickly go out to the other model, and that way we'll hopefully have at least a few minutes for some questions. And Dave's going to help me monitor the chat window and the Q&A if possible. So we want to go back out, and instead of doing the single 24-hour storm event model, we'll look at this multi-year model. So we'll click on that. It'll calculate a lot more data, so it takes just a few more seconds. And as I mentioned earlier quickly, that it is actually analyzing and modeling precipitation data averaged for a year over a 20-year period.
And this is using a model routine called MapSheds, which is freely available if you search that on the internet. It's out of Penn State, and it's been used for total maximum daily load modeling for the state of Pennsylvania for many years. Dr. Barry Evans is the author of the model based on general watershed, linear watershed function model, and is currently only available to run in the Delaware River watershed and the entire state of Pennsylvania. And we hope in the future to expand that to other parts of the United States.
And so this multi-year model is very exciting because it has lots of other data. Hydrology data is shown here, and as I said, precipitation is the real data that it's based off of. And then it also calculates using algorithms evapotranspiration, surface runoff, subsurface flow, point source, flow, and stream flow. And so we'll leave it on precipitation for now. And you can see those precipitation rates averaged over a year's worth of time based off of that 20-year data, both in graphical form and tabular form again. We click over to water quality data. Then we have the information about the sediment load, the nitrogen, and the phosphorus load, also within that multi-year model, and within also what sources it's coming from within the polygon that you've selected, and individual rows of data up top, and then information at the bottom like total loads for sediment, total nitrogen, and total phosphorus, which I know a number of people are interested in. We're working with watershed groups within the Delaware River Basin. In addition to the loading rates, annual concentration, and low flow concentrations. So those are available under the modeling tool. Similar to the single storm model. Oh, Dave, go ahead.
So this is considered the first step in the Mapshed model. And if at this point you would prefer to use this information to drive the desktop model that you can download for free off the Penn State website, there is a download function for the project that puts all of this information into the file type that Mapshed requires, and that is available with the small triangle drop down off current conditions. You can export as GMS. So it's a little bit more technical for some of the maybe the professionals out there. You can get a single file that becomes your starting point for Mapshed using that independent desktop software.
Great. So similar to the other model, the single 24-hour storm event model, this multi-year model also lets you model new scenarios. And there's a slightly different set of conservation practices here. Some of them they're listed within rural and urban areas. So say, for instance, we want to put in some vegetative buffer strips or cover crops or do some nutrient management. It's different options, or infiltration or bioretention basins. Let's say we do some vegetative buffer strips. It already knows within my polygon that I've selected that there's 1.92 kilometers of length of streams in non-ag areas. And how much we get to choose our scenario and model how much of those we want to convert to a vegetative buffer strip. So let's say we do about 50%, so 1.0 kilometers, and then we apply that. It recalculates using the models, the Mapshed's model in this case, and we get new rates for both hydrology and water quality, and these numbers would change depending on the different scenarios. We can do multiple scenarios just like before. So maybe we planted, we've got 48 hectares of row crops are identified within the polygon I selected. Let's say we get a large number of those converted, 93% of those converted to cover crops, which is a good conservation practice to use. It's recalculating for hydrology and water quality. Again, so you have those different numbers. We can do multiple ones within the same scenario. And so maybe we do, we have some conservation tillage. We change some of those. Well, that would be also the row crops. Let me do a different one. That's also an agricultural one. Let's switch to stream bed stabilization. So we've got those length of streams again, and we change some of those using a different model or different method than we used before. So you could do multiple ones, and this little key on the side shows you which ones you've chosen. We don't have a compare function on this tool yet, this model yet, but that's also something that will be coming soon, so you can compare all your different scenarios. Last thing before we get to some questions, I see there's a couple questions listed already in the chat window. We're going to get to those. If other people have questions, please do write those over there. You can start doing that, adding to that list. We're going to start answering those in just about 1 minute. You can title your projects. As I mentioned earlier, you can share it. You can make it public and share it with lots of other people. So you can do these modeling scenarios. You can share them. If you're in a classroom, your students could share them, and it basically is copying a URL, and your students could send that as an email to you and share that URL of their final product. So I could envision, I could see that happening as a final project for a unit on watersheds, where they're doing the analysis and the modeling and creating or proposing changes in conservation practices and land use changes, and then being able to make those public and share them with you as the teacher. And the same thing is happening by citizen scientists, by watershed groups, by scientists, by municipalities that are proposing land use changes or zoning ordinances or any type of stream improvements or proposing new housing developments. They also are able to use this tool, all based on scientific models and algorithms that have been used in other models. Now they're embedded in this nice, easy-to-use tool we call Model My Watershed. So let's dive into a couple of the questions. All right, let's see.
Q&A window as well.
Okay. Let's see. One of the questions is, will you keep the technical version of the video? Yes. The technical version that's of the archived video is available, and it will remain available. As we do another webinar in the future, that's a technical one that shows you all the underlying, or talks about all the underlying models. We'll probably replace the older one that's there, but there'll always be at least one of them in place. All right, so here's our Q&A.
Well, another question over here about, is this only good for current conditions? For example, what about winter? Yeah, these are average conditions during the growing season for the Sightstone model. The multi-year model incorporates actually weekly precipitation events over the entire year, and those records are averaged over at least 20 years, I believe. So what you're looking at is the average conditions over the year by month.
I can give one other example with that too. Last week I did a webinar into a conference in Colorado, and one of the things we figured out was if you're in a perennial ice or snow cover area, though, it does treat it as an impervious surface. So you would get most likely 100% runoff. So if you're above 14,000 feet in Colorado and you're doing some modeling, then it does treat it as a perennial ice area. But that's not quite as many people will run it, that example.
A couple of platform-specific question. Notice we're on a PC. Does this work equally well on a Mac? Yes, it does. It works well. It's a web-based program, so you can access it from any machine that you have that can access the internet. It is not necessarily optimized for very small devices. Although you can access it on your smartphone, you will not have the same experience that we're showing here.
Yeah, we did do a recent update that created some optimization for iPads and tablets that gives different screen views that tries to maximize your screen view. But it's just a smaller screen, so it's hard to see all the different functionality when you're on a smaller device. And we also recently released about 6 weeks ago an optimization package for touchscreen devices, both with as laptop computers that have the touchscreen capability, but also, of course, iPads and similar devices to that.
Why don't you answer that one?
Okay. Let's see. Wait, a question. Will most of the functions work for California watersheds? Yes. Most of what's in here is for the lower 48 states. The items that don't work are the items that we're piloting in the Delaware River Basin. And all of those are labeled as either DRB for Delaware River Basin or something very similar to that. But all of the modeling for changing land cover or conservation practices, and all the analysis. All of that works across the entire lower 48. And one of our pilot states is California for the education curriculum. It's California, Iowa, Kansas, Pennsylvania, and Virginia. So we have a group of teachers in California. Let's see. Let me just scroll down.
So I've just clicked on a watershed near Sacramento, and it has clipped the Huck 12 basin, and it is doing that first analyze part. The watershed multi-year model will not work outside of the state of Pennsylvania or in the Delaware River, but the Sightstone model does work.
We request a search for certain watersheds. That's a good question about how to search for certain things. Right now, the search tool, we'll go back, it's not by name,
street address.
It's by street address. So to go way back to the beginning, you have to put in a street address here under where the search is. It doesn't allow you at this point to do like a Google search of place names. So we do need to search at this point by search for any street address within the watershed. Let's see, some other couple questions in our last few minutes.
How often are data updated? This is somewhat dependent on our funding, and we are in between funding cycles, major funding cycles, and have some updates still coming through. We're working with our tech team at Azavia and elsewhere, and if we have updates, they're released on a 6-week cycle, and we will not have any major updates aside from bug fixes for the next couple months, but we hope to get back to deploying new functionality sort of in the spring of 2017.
All right, here's a question from Texas. Let me see if I can understand this question. So do the overlays populate based on the location you're looking at? For example, I'm in the Dallas-Fort Worth area, so would my overlays be representative of my location? Yes, they're representative of your location. So if we're looking at overlays here, I'm not sure if I'll see if I'll answer this question correctly or not. And all this national stream network is across the lower 48.
So there, I think what's embedded in there is the age of the data as well. And we are working on documentation, but for example, the National Land Cover Database 2011, the Streams Network is nationally from the USGS from their NHD plus data layers, and as new layers are published, we have every intent to freshen up these layers in the app.
So here we zoomed into, here's Dallas-Fort Worth there, or Fort Worth, and we see a lot of urban colors in red in our National Land Cover Database. And also we can switch over to hydrologic soil groups and we can see those data populating also from that database.
And it's important to recognize that the process of generating land cover data is from image interpretation from satellite or aerial images, and there are limitations to that process that result in inaccurate land use categorization, although the algorithms are getting better to show that. But one way you can take a look here is changing the transparency of this land cover or soils over this geographic area of interest. And then if you see a problem with the classification, of course, you can always modify your project to change that land use to what you know is in fact the real land use.
Okay, I'll get an easy question here for me. How do you make the layer sidebar appear? That one's easy for me to answer. Let me turn it off so I can show you where to find it again, because I've just had it on the whole time. It's actually this little show layer control globe icon. If you click on that, then you get these layer controls button, base map overlays, and observations. And when you have the National Land Cover Database or hydrologic soil groups enabled, you also have a function to change the transparency of those. that goes away if you take those away also. Great, I like easy questions.
We're running towards the end of the hour, so if there are more questions, maybe one or two more, but I think we have answered the questions that have come through.
All right, great. We'll go back and point out that you find these resources at WikiWatershed.org. And our feature resource for today was Model My Watershed, our feature tool from the toolkit. We'll continue to have additional webinars into the future, and we'll highlight these other tools within the toolkit. And we'll likely continue to do other Model My Watershed webinars, because as we go into the future, more and more features are being released.
And I would end my contribution here by letting you know about the donate button. We do bring this resource to everyone for free, and do have some long-term maintenance costs that we'd like to help cover. So if you feel so inclined, we'd appreciate any amount, and you can donate through that corridor there.
Contact button also, if you have additional questions, or also you can submit feedback or ask additional questions in the future.
Report a bug.
So report a bug or submit feature requests that you'd like to have. So you can do those within these features here within wikiwatershed.org. And were you saying you wanted to say it? Back in the end, the end result is that this is a product brought to you. We're happy to bring this to you, as Dave said, for free. Product of the Stroud Water Research Center. Please check out many of our other resources and programs in the science and restoration that we're doing, not just in our local area, but all right. Well, thank you. Thank you all for joining us. We'll go ahead and we're going to close down the webinar. Please use that contact form from wikiwatershed.org if you have additional questions or ideas or want more details. And we'll someone from the team will get back to you answering your questions.
Thank you all for attending.